Okay, so another formula that we use with geometric shapes is a distance formula, and especially again trying to build up to circles. So say again I have the same line segment 1, 5, and 7, 7, and I want to find the distance of this line segment, so the length of a line segment. So I want to know how long this thing is. Well, I can't just subtract because, well, they're on different levels. Averaging kind of worked to find a midpoint. I already found a midpoint of these, but that's not really going to help me find the length of it. One thing I can do though is I can try to draw this into a right triangle. Let's see why I want to do that in a second. If I draw this into a right triangle, then this would be my length across from my right angle, so this would be my C. And we're going to call it a C, my hypotenuse, because we want to use the Pythagorean theorem. So if you all remember the Pythagorean theorem, it's a squared plus b squared equals c squared. So if I have this being a c, then maybe I could find out what my a and my b are and actually solve for that. Well, I'm going to try to find out what this point is, this kind of right angle point that I drew in. And if I look at this, this is on the same level as this point on my y's. My y's are up here. So right here, this is a 5. So this is on the exact same level. So this y should be a 5. And this point is on the same level as this according to my x's, or in terms of my x. This was on the 7. So this is also on the 7. So I actually know that point. So if I look at this, I should be able to figure out this length. This length here goes from 1, 2, 3, 4, goes all the way to 7. So I can figure out this length just by saying what is 7 minus 1. My length would be 6. I should be able to figure out this length. This length, it's on the same x, so I can just look at my y's and say this went up 2 spaces. So this length should be 7 minus 5, or 2. Again, I can use this for Pythagorean theorem. I could say, make that equals a little bit more, 6 squared plus 2 squared equals c squared. So 36 plus 4 equals c squared. So c equals square root of 40, because I'd want to square root solve for the c. I'd probably simplify it. I would probably say 2 root 10. And I would know what this distance is. So that would be useful for ones where I already had the point. But let's see if we can generalize it a little bit. So I found this length by subtracting, really, my 2 x's. So I found this length by doing x2 minus x1. I found this length by subtracting, really, my 2 y's. So this was y2 minus y1. And then I put those lengths that I found, the 6 and the 2, into the Pythagorean theorem. So I put x2 minus x1 plus y2 minus y1 into the Pythagorean theorem. And I said that my distance was c. Since, because that was my hypotenuse, I usually call it c. Since I'm going to say this is the distance formula, I'm going to replace that c with the d to stand for distance. I probably want to solve for that d, so I'm going to go ahead and square root both sides. So I'm going to have x2 minus x1 squared plus y2 minus y1 squared, all underneath the square root. Usually when you take a square root in an equation, you need to write the plus or minus in front, but since it's a distance, I can only have a positive distance. So I'm just going to leave it with a positive in front, no minus. So this is distance formula that we're going to use in talking about circles.